Find the time period oscillation of mass m. Both springs have the different spring constant K1 and K2. So we will use the shortcut method first. Suppose I say I mark the tension, here the tension is T, then here the tension is given by 2T. For the spring 1 we will say K1 will be written as, where K1 dash can be written as a K1, and tension of the block upon tension of the spring whole square, so it is given by K1. Tension of the block is given by 2T and tension of the spring is given by T, so we will calculate it is given by 4K1. Similarly we will calculate the K2 dash. K2 dash is written as the K2, that is exactly same tension of the block upon tension of the spring, so it is given by 4K2. And we know, we will assume both the springs are connected in parallel, so 1 upon K equivalent is given by 1 upon K1 dash plus 1 upon K2 dash. So K equivalent is written as the 4, or you can say 16, 4 for 16 K1 K2 upon 4 common K1 plus K2, or you can say that is 4 K1 K2 upon K1 plus K2. And we will calculate the time period oscillation 2 pi root m by K. So in place of the K equivalent we will write here 4 K1 K2, and here you will write K1 plus K2. So answer of this problem is given by 2 pi root m K1 plus K2 upon 4 K1 K2. I will discuss one more method here. This method is known as the Hyde spring and energy method. Firstly, we had the spring number 1 like this and displace the block by distance x. So we know if this is the you can say string, so here the displacement is 0, here displacement is 0, here displacement is 0, and here displacement is 0. If it is displacing by x, definitely here displacement must be given by 2x. It means energy is stored in this spring, we can say spring 2. So energy is stored in spring 2 is given by half kx square, so half k2 into 2x square, we will say it is given by half k2 into 4x square. Okay. Now we will hide another spring, just erase it. We hide this, again displaced by x, again here displacement is 0, here displacement is 0, of course displacement is coming toward this side, this must be 2x, so here displacement is 2x. It means energy stored in spring 1 is given by half, that is k1, then 2x whole square, so we will say it is half k1 into 4x square. Okay. It means we can say spring constant, here it is written as the 4k1 and here it is written as the 4k2. This is a spring constant. Now assume both the spring having spring constant 4k1 and 4k2 connected in series with the mass m, and again we will calculate exactly same answer because k equivalent further it will be written as a 4 k1 k2 upon k1 plus k2, and k equivalent is given by a single mass block, it is m omega square. So omega easily we will calculate, it is given by root 4 k1 k2 upon k1 plus k2. So time period oscillation is given by 2 pi root m k1 plus k2 upon 4 k1 k2.